So let's talk a little bit more about graphing. So when you're graphing, the independent variable is always going to be plotted on your x-axis. The dependent variable is always going to be plotted on your y-axis. Use the mnemonic dry mix to help you remember that. So the dependent variable or the responding variable, it responds to the independent variable, is always plotted on the y-axis, so that's dry. And then the independent variable is also the manipulated variable. It's the one that you're changing on purpose. So manipulated is the independent variable, and it's plotted on the x-axis. Again, dry mix. Use that to help you remember which variable to put on which axis. Make sure you clearly label both axes. Make sure you include the units on the axes and close those in parentheses like so. Provide a descriptive title. I like to use the pattern, the effect of the independent variable on the dependent variable. So for example, if we were graphing Miracle-Gro concentration used on plants against plant height, we might say the title would be the effect of Miracle-Gro concentration. So that's my independent variable on plant height, which is my dependent variable. So independent, dependent. So if the instructions are to plot your points rather than graph them, there's no need to draw a line. If you're asked to draw a line, don't extend the line beyond the last point that you plotted, and don't connect the line to the origin unless you have a 0 time reading. Only connect a line between the first point you plotted and the last point you plotted. If multiple lines are to be put on the same axis, make sure that you include a key or that you clearly label each line, and use a line of best fit when appropriate. So if there's clearly a linear trend and you have some points that maybe look like this, you want to draw a line of best fit down the middle. You don't want to just connect a snake like so. Use a line of best fit to show the pattern. So here's an example of a kind of question you might be asked. So an agricultural biologist was evaluating 2 newly developed varieties of wheat as potential crops. In an experiment, seedlings were germinated at 20 degrees Celsius for 48 hours. Oxygen consumption of the 2-day-old seedlings was measured at 17 degrees Celsius. The data are included in the tables below. Graph both sets of data on the included graph paper. Calculate the rate of oxygen consumption for each variety between times 20 minutes and 80 minutes. So first of all, we want to graph. So we got to think about our variables here. So if time's involved, it's pretty much always going to be plotted on the x-axis. So let's go ahead and say time down here. Whoops, let's try that again. Time. We are measuring time in minutes. So that means we're going to plot oxygen consumption on the y-axis. And that's in milliliters. So let's, first of all, we need to decide how much each line on our graph means. So our times are 0, 20, 40, 60. So that would make sense for each one of these marks to be 20. So 20, 40, 60, 80, 100, and so on. And then our oxygen consumption, it looks like it goes up to 5. So it might make sense to make each of our lines here to be maybe a half. So we could go 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4. Whoops, that's not going to work because we're going to go past our axis. So let's just make each one be 1 milliliter of oxygen consumption. So 1, 2, 3, 4, 5, 6, like so. And let's plot our points. So let's plot variety A first. So 0, 0. And then we go to 20 and 1.4. So go over to 20 and up to 1.4. So somewhere right there. And then let's go 40, 2.6. So somewhere right in there. Over to 60 and up to 4. And then over to 80 and up to 5.2. So this is graph both sets of data. It doesn't say plot, it doesn't say to draw a line. So we've plotted the points. Notice that they are very linear. So let's go ahead and draw a line of best fit, remembering not to extend past my last point. In this case, I did start at 0, so that's good. Now let's go ahead and plot the second set of data as well. So again, we have a 0, 0. We have a 20 and a 0.8. We have a 40 and a 1.6. We have a 60 and a 2.4. We have an 80 and a 3.2. So again, we got a pretty good set of linear data. Drawing a line, let's label them. So this variety A, variety B. All right, and now in this case, we're not really looking at an independent and dependent variable here so much. So we might say a title might be oxygen consumption. We can just call it oxygen consumption by different wheat varieties. Now we're also asked here to calculate the rate of oxygen consumption for each variety between 20 and 80 seconds. So let's do variety A first. So at 20 seconds, the oxygen consumption for variety A was 1.4. So we have a point, 20 and 1.4. And at 80 seconds, right here, our point was 80 and 5.2. So again, we calculate rate. So remember, it's the slope. And the slope between those 2 points is the change in y. So I'm going to go 5.2 minus 1.4 over the change in x. So 80 minus 20. So if we calculate that out, 5.2 minus 1.4, that gives us 3.8. On the bottom of this, we have 60. So if we divide 3.8 by 60, that ends up giving us 0.063. And our units on that would be our y units, which are milliliters, divided by our x units, which are minutes. So that's our rate for variety A. Now for variety B, we're going to do the same kind of thing. Let me erase a little bit here. So we're asked to calculate, again, for 20, between 20 and 80. So here's 20 and here's 80. Our point at 20 for variety B was 20 and 0.8. And at 80, our y is 3.2. So again, to calculate the rate, take your change in y, 3.2 minus 0.8 over the change in x, 80 minus 20. So let's go 3.2 minus 0.8. That gives us 2.4. On the bottom, we have 80 minus 20 to get 60. So if we divide 2.4, the top, by the bottom, 60, we get 0.04. And again, that would be milliliters of oxygen over or per minute. All right, so that's doing a graph and calculating a rate by calculating a slope. Hope that helps.